let's say that instead of going across the stream, you're in an airplane. And your airplane, you're going from Midland to Dallas. And it's pretty much a straight line, isn't it? We're headed straight east, Big D, and then there's the Petroplex. Okay? So we're headed from Midland to Dallas. And you're in a plane. And this plane can go a maximum speed of 600 miles per hour.
Huh?
Okay? Because you're flying some friend's private plane, and you're not going Southwest, you're just going a private plane because you've got really good friends who have private planes. And so you've got a maximum speed of 600 miles per hour. You've got to end up here, but there's a wind. And that wind is blowing straight south. And that wind is blowing at 60 miles per hour up high where you're flying. It's a pretty strong sustained wind. If you direct your plane straight across, what's going to happen to you?
You're gonna end up way down there.
You end up straight down, don't you? So what are you going to have to do? Go at an angle. So if you're flying your plane at an angle to get across, then the maximum speed your plane can go is still at that angle, right? So the angle is going to be something like this to offset that, isn't it? If I wanted to know at what angle do you have to put the course on your plane to make it, how do I figure that out?
You find the distance between Midland and Dallas.
Could you just
Oh, well,
Inverse tangent of what?
opposite over adjacent.
What's my opposite?
Just get speed, you don't have to.
60.
Okay, so 60 is my opposite. That would make the angle there, right?
Mhm.
And then my adjacent.
Isn't that 600?
Mm.
What's the hypotenuse?
Because the plane is going 600 and it's going that direction.
Hypotenuse is 600? So
The
you need
hypotenuse
to
is 600.
opposite over hypotenuse.
So yeah, opposite and hypotenuse. So what do we use for that? Hmm? Sine. So then, if sine of the angle is equal to opposite over hypotenuse, if I'm getting the angle, what do I do?
Inverse sine.
Inverse sine of opposite, which is 60, over hypotenuse, which is 600. So inverse sine of 0.1, and what do you get? 5.74 degrees. So if you're going to make it straight across, you actually have to aim for a bearing of 5.74 degrees. And how would I give that direction?
Northeast.
North of east. Because here's east, and I'm going 5.74 degrees north of that, aren't I? Does this make sense to you?
Yeah.
So when the airline pilots are flying, they're having to look at this information. What's the wind speed and all that? It's not going to stay the same the whole time. So they're constantly having to adjust, and that's part of their training, is just kind of looking and say, okay, I know that I'm going to have to adjust a little bit this way. But let's look at this other thing. If they're going 600 like this, okay, this part of the triangle 600 miles per hour, what does that mean about this right here? What's their speed along that? More than, less than, or equal to 600?
Less than.
Less than. So what's going to happen to the speed, or the time it actually, what's going to happen to their speed as far as traveling from here to here? Slower. What's going to happen to the time it's going to take them to get there?
Slower.
It's going to take more time.
One more time, yeah.
Okay? So how would I figure out how long it would take to go from here to here? Let's say that this distance is right at 350 miles. if I ask for how much time does it take to go from the Petroplex to Dallas in that 350 miles, how would I go about figuring that out?
Would you have to find the speed of the horizontal line, or would you use? the
You
600?
would.
So
What would I
then
use to figure out the speed of that horizontal?
Pythagorean theorem.
I could use the Pythagorean theorem for one thing, right? I could take and say a squared plus b squared equals c squared, which means I could say the hypotenuse squared c squared minus b squared is equal to a squared, right? So I could solve that way, and if I called this a and this b, of course the hypotenuse is c, I could do that. So I could take the square root of that right there. There's also another way. I have an angle and a hypotenuse. What side is this?
Adjacent,
Adjacent. What can I use for that adjacent side with an angle and a hypotenuse?
cosine.
Cosine. I could say the hypotenuse times cosine of the angle, 5.74, is equal to that speed, that adjacent side. Is this making sense to you a little bit? Okay, so what's that value gonna be? 596.999,
596.99.
so 597-ish.
Yep.
So we don't lose too much with that, do we? Okay, so what's the time gonna be then to get there? We have a speed and we have a distance. How do we get time?
Divide distance by speed.
So what do? Flip those, right? 350 divided by 597, and I get time
0.59 hours.
how long?
0.59.
Which means a little more than half of an hour, right? 0.6 of an hour. So 36 minutes.